Morning, everybody.
Hello.
Should we move on with our HMI stuff?
Yes.
Survey says. Survey says share screen. All right. Well, where were we? Oh, we were going to show fan speed. I'm going to download this to the PLC. All right, so what were we gonna, okay, fan speed. What were we gonna do, a numeric display? So we show the display in hertz. Is that what we said we were gonna do?
Yeah.
Yes.
Yeah.
Okay.
Sorry, I'm eating a bowl of cereal, so I have myself muted.
All right. Well, what do we want to make this look like?
Pink.
Pink. So we're gonna have one for temperature fan, and we'll have one for
Or what?
pink and yellow, pink and yellow, pink and yellow.
Oh my god.
Temp fan speed in hertz. So let's do 2 digits, 1 decimal. And the data display tag is, what's our fan speed in hertz? Do we have a fan speed in hertz?
I'm not
Isn't
sure.
rung 8? I thought I saw.
Well, here we're just moving those values. But did we ever create a rung that outputs just the fan speed.
No.
Yeah, we did. Rung
Did we?
20 and 21.
Oh.
Right now they're at 0. So it looks like F8.4 is exhaust and F8.5 is temperature. Okay. And exhaust fan speed is F8.4. I'm just gonna, what color do we want this one?
Green.
Green?
Green. Yes. Green and blue.
Should we make it blink?
What do you mean blank?
Oh, you see this? Yeah, this option here. You see what the number's doing? 12.3 is flashing.
Oh, blank. So you said blank.
Please.
So that's going to be F8.4.
I have a seizure.
All right, should we test it out?
Yeah.
Please.
You know what? Let's put some more stuff on the screen. Let's make it like all the outputs. So like all the pilot lights and everything. See what I'm saying?
So like it displays when they're energized.
Yeah. So if somebody's got a piece of paper and a pencil, let's write down everything we can display. Left green pilot light is 40. Somebody writing this down?
I'm doing it.
What?
Left green pilot light is 40.
Yep.
Okay.
Right green pilot light is 20.
Okay.
Water heat and stir is 47. Got the fan speed. Ooh, we could have the digital display on there too. What is the digital display doing in this? Showing us temperature.
Yeah, and wasn't it in Fahrenheit?
Output 5 channel 0 data.
Yeah, that's the digital display.
What is 50? Oh, what is F82? Okay, invert degrees Celsius. Okay. So we can have a digital display in degrees Celsius. So where is our degrees Celsius? F81. So write down degrees Celsius is F81.
Degrees Celsius F8.
Temperature heater is 4.1. The bottom red pilot light is 2.4.
Two, four. Okay.
And the strobe is 2.0. That's it.
2, 0. Okay.
Let's add all that stuff. We got, how many pilot lights do we have?
We have two pilot lights. Yeah.
Three.
Oh,
We
three.
got
Three
left
bottom
green,
red.
right green, and bottom red.
Okay, so what is the, give me, what's the first one?
Left green.
What is that?
4-0.
What is that doing though? What is that indicating? Left green pilot light is control on. So left green is control on. Right green is water heat and stir. What was the other? There was a red pilot light, wasn't there? Bottom red. So bottom red is the temperature heater. The strobe is the temperature fan. So what did I say? The left green pilot light was control on.
On.
And that, what's that one?
4-0.
We're gonna have to assign B3s to all of those. Maybe. What is 4.0? Okay, we can use B30 for the left green pilot light because it's in parallel with it. So I'll make this B3. Everybody understand that? B30. Instead of creating one, we already have one. Oops. Okay, so control on pilot light.
So you're using left green pilot light as B30 because it's in parallel.
Right. What's the next one? What is the right green pilot light?
2-0.
output 2-0.
Correct.
So it's gonna be 4-7 or that's right green is 2-2. Maybe I said that wrong. Yeah, so we're gonna have to create a bit for that. So this will be, which B3s are we not using?
2-2.
B310. Call that um, HMI water heat stir. We need another one that's flashing so we can simulate this will be V311. This will be HPI, HMI. Green. Everybody following what I'm doing?
Mm-hmm.
Yes.
So if this is the right green pilot light is water heat and stir pilot light.
Yep. And
It's going to be B311. So what is our red pilot light? Temp heater?
Yeah.
bottom red pilot light 2-4 temp heater.
All right, we're gonna have to create a bit for that.
Did you know that with stained glass they solder it? That's weird.
Who didn't know that?
I didn't.
What was that fun fact?
With stained glass they solder it?
Why?
to like keep it together. You know, like how like the stained murals and like churches and stuff, they use soldering in between each pane of glass.
That's crazy.
That's what I'm saying.
Because like, how old is some of like the oldest stained glass pieces? And they knew how to do that?
Like more modern things, but sure.
Sure. Okay, fine.
I bet they have like the same technique though, like melt a metal down and put it in between.
Yeah, that's what I'm saying. They were so smart.
So Zach, could we put images on the like JPEGs or MP instead of like colors on the buttons?
On the buttons?
Yeah.
Don't think so. Maybe there's a way to. I don't know for sure, but I don't think so.
Because it'd be cool to like have Sonic the Hedgehog on our start button.
Yeah. HMI.
No.
No, Aaron, it would be cool. Also, I had a theoretical question that's not related to this. So, like, what would theoretically happen if, like, you had a giant sheet of copper and you put your two inputs on one side and like two outputs on the other? Would it just flow through regularly, or would it create a short?
What? A giant sheet of copper.
Correct.
Okay, and you did what?
You put like two different circuits on it.
It would short.
It wouldn't. Yeah, that's what I assumed.
It would definitely short. Yeah, there's no way that would work.
The entire sheet of copper is a conductor.
Yeah.
Yeah.
So like it's going to flow from one side to the other, no matter what circuits you put on there.
It's all bleeding in together since it's just one sheet of copper.
All right, what were we doing?
HMIs.
That's awful.
So the bottom red pilot light is going to be B313. It's going to be the temp heater pilot light. It's going to be red.
Look at that. That's beautiful. You're doing a great job, Zach. I don't think people in this chat tell you that enough.
Thank you.
You're welcome. That off looks. Oh, it's clear. I get it. I get it.
Temp heater pilot light. All right, so there's our pilot lights. We have a water heat. We have a water heat and stir output. We have a temp heater output. So what are those?
Temp heater is bottom red pilot light 2-4. Oh, temp heater 4-1. Sorry.
Well, we had to go through and make B3s for them. So the temp heater pilot light is going to be B3
13. Temp heater pilot light.
or the temp heater is going to be B312. That's just going to come on when the temperature heater is on. We're basically creating our own pilot light on the HMI, right? What did I just say it was? 12? Heater. And when our outputs are on, what do you want to make them? Yellow?
Sure.
Sure. Yellow, making that, yeah, that nasty yellow. brown, yellow.
I'm so sorry, guys.
When they're
Shane, is
off,
that you?
it'll be this
Yeah.
Oh,
nasty yellow. So here's off, on, off, on. Okay. B312. Okay. And this will be the water, heat, and stir. It's going to be B310. Just make those a little different since they're not. So the top ones are pilot lights and the bottom ones are the actual outputs. All right, what else did we have on there?
Strobe.
Strobe. What is the strobe?
Says output 20.
Output 20. So we just need to make, what's the next B3? 14?
I think so.
HMI strobe output.
Output.
So the strobe is going to be B314. So when it's energized, we'll make it red and we'll make it blank since it's a strobe.
Oh.
Cool.
That's pretty.
Yeah, that's very cool.
And we're gonna have the 3-digit display, right?
Right.
Which is displaying temperature in Celsius. What color do we want that? Probably like a purple. And really ugly, like brown. Oh yeah, purple and brown goes together.
Oh yeah.
All right, and what is that output? Should be an F8.
FA1.
That's temperature in Celsius.
Yep. Is anyone gonna second that?
Why don't I look? It goes down at the bottom, right?
That's what I wrote down.
F8-1. Is that all of them?
I believe so.
All right, I'm going to, what am I going to do? Save this as five, one. And I'm going to send to the panel, transfer. And then I'm going to stop the share so I can show you. You see the HMI?
Yeah.
Yes.
All right, so what do we have? Process enable. If I do that and go over to our outputs, so the fan speeds are at, why are they at negative 0.6?
Because that's how fast a fan is supposed to go, Zach. I thought you would know this as an electrician.
Yeah, I mean, that's just totally normal operating.
Why would it be at negative 0.6 hertz? Should know this.
Oh,
Because you have it like the 6,000 number, not the 624.
What would 0 hertz be?
Wouldn't it fault it?
6241.
Yeah.
Yeah.
That would show 0. But we don't want to output less than 3 milliamps to it, so we use that 6,000 number. Okay. Are you able to read this? Because my screen is really tiny. I don't know if I can.
Yes and no.
Yes and no.
Like the ones in the middle, well, the smaller ones besides temp fan speed and exhaust fan speed, you can't really read the titles.
I pinned the video. It's blurry, though.
Blurry. I don't know if this camera would be better. No. What we can do is make the the text on these a little bigger.
So is the fan actually spinning in reverse or something because it's negative 0.6?
No, it's just less. It's outputting less than 4 milliamps to the drive.
Makes sense.
Stand by. I'm just making the text bigger.
So you could apply, I guess you can't really apply negative voltage to it, but in a sense, it's changing the legs is one way to do it, but -4, less than -4 milliamps would be negative direction in the other direction. Something. Yeah.
All right, I changed all the text, so now hopefully it will. Loading. I got it enabled, and then I'm going to do the temperature control start, and then I'm going to go monitor the fan speed. So right now the exhaust fan is on, the temperature heater is on, the water heater and stir is on, the strobe light is on, water heat and stir pilot light is on, control is on. What is this one?
Computer pilot. Oh,
Shouldn't that be on since our temperature heater's on?
This is the strobe. No, that's the.
Bottom red pilot light, is it?
This is the strobe. I just mislabeled this. So this is when the temperature fan is on, the strobe comes on, right? The temperature heater pilot light is flashing. The water pilot light is flashing. This will be the strobe. So why is this not working? Temperature in Celsius. 7.5, negative 0.5.
What's 7.5?
It's telling me what the temperature is in Celsius. And I don't understand that.
Degrees Celsius was FA1. I know that.
7.3. That puppy's getting hot. I don't understand why the temperature in Celsius isn't reading right.
Is it a conversion?
Is our actual digital display showing the temperature?
No, it's showing. See, right now it's reading.
Right.
That looks right. I wonder if the puck that's converting it to milliamps is going bad. So this is running every 10 seconds. Remember, we put it on a timer so it wasn't so janky. So let's see if the next 10-second read is accurate. Yep. Let me run it again and see if so now it's reading. I wonder what the deal is.
So that expression, the destination is from the expression, the DEST.
Yeah. Can you guys read the HMI now?
I can.
Okay, so what is the temperature? When this temperature gets to a certain value, it's 100 degrees Fahrenheit, you're going to see the fan turn on and you're going to see the strobe light start flashing. I don't remember what that temperature is in Fahrenheit. Oh, can you see the logic on the screen too?
Yeah.
If we swap the video, yeah.
Okay, so on rung 10, this temperature F83 is going to get up to around 100. When that happens, I don't know what the temperature in Celsius is. But when that happens, the temperature fan should kick on, and then you'll see this strobe turn on.
It's not doing anything. Well, oh yeah, now it
Should
is.
start climbing pretty quickly now because there's just a lag between the soldering iron heating up the thermocouple, and then there's a 10-second delay.
Do we have the tempeater like just saying on or off instead of flashing on and off?
The temperature heater on the output itself is the yellow square looking deal.
Okay.
So do you see on the HMI the red temp heater pilot light is flashing? That's the actual pilot light. And then down below it, that smaller box, it says temp heater. That means that the output itself. So the soldering iron is on right now.
Okay. So why is it flashing on and off?
That's how we had it according to our
Oh. Gotcha.
Is it just going to 80 degrees? Because it seems like it reaches around 80 and then goes back down.
Should be. Should keep going up. I mean, that thing is. Put my hand over it. It's hot.
So I mean, it went from 82 to 78, and the last time it went from 81 to 24.
I wonder if it just isn't getting hot enough. I think I don't know. There's got to be something loose. But we can change it in our logic to 80. Temperature sensor is less than. Can make this I don't know, 1200, and make this 1200. 12,000. Okay, there's our strobe. Our fan is up at 60 hertz. Temp heater turned off. We'll see the temperature in Celsius go back down, hopefully. Going back down.
Deep Space Nine. Final Frontier.
Temperature's still going up. It's working. It's just taking forever because of the lag. Wonder if we use like we used an RTD instead of a thermocouple. The RTDs are a little more accurate. Well, do we want to sit here for another 20 minutes and wait for the temperature to go back down, or does everybody understand the concepts? I mean, as long as everybody understands why I went through and like put the B3s in there so we could use them in the HMI program.
Yeah. I don't know. I think another 20 minutes sounds pretty exhilarating. So.
You don't want to sit here and watch paint dry with me? The last thing that I want to do with these HMIs is add these entries. So like if we added another screen and we put a numeric entry in there, we could like let's say from the HMI you wanted to control. Oh, I'm not even sharing my screen. Okay, let's say from the HMI, I wanted to have another screen where I put this numeric entry in there. What that's going to show is this entry. So if we made this fan speed in hertz, you can have the user input, okay, I want the exhaust fan to spin at whatever, 90%. So then they would come to this keypad, they would hit the keypad, and then hit in 90 for percent, enter, and then the exhaust fan would start turning at 90%. You know what I mean? So it's like a user input. You can have it that way, or you can have a thumb wheel. Looks like this, so you can input, you know, hit 60. But we don't have time to do it today because we'd have to go into our logic and like for the temperature fan, wherever that one is, bypass this exhaust bit with another I don't know if we can use the selector switch. So when the selector switch is in the right position, it will allow us to input data manually. You know what I mean? Am I talking to myself, or do you guys understand what I'm saying?
No, I get it.
I understand what you're saying.
So we'll do that next time. I guess Monday then, right?
Yep.
Yeah, Monday.
Still got to figure out. Let's plan on Monday. Please be here so we can schedule the final exam programming doodad with me. I got to come up with the dates. We'll make our schedule on Monday though, and do a little bit of HMI work if time permits, and then from here on out, then during our 232 sessions, we'll just be covering anything you guys want to go over that has to do with that final exam program that I posted.
Okay,
Alright.
sounds good.
So we'll do a little bit of HMI work on Monday. We'll schedule our final exam sessions, and then from here on out, then it'll be final review kind of stuff. So we've only got a couple weeks left. Does anybody know when they pushed back the final exam schedule to?
No, I'm not sure.
I'm gonna look it up here if you want to stick around.
Wouldn't it be like a week since we were pushed out of spring break a week?
Probably.
Yeah, I mean, they just extended it a week, but I don't know what the exact days are. And we're going to have a few days, you know, like if everybody's going to have 2 hours to write the program, people are going to be doing it in different days. So,
Yeah.
well, this is 2020, so that doesn't help.
Does anybody know what we're supposed to do if we ordered a cap and gown or if we have to return books?
That's a good point. I moved to Oklahoma and I bought a cap and gown.
I heard that they were sending out cap and gowns for free due to the coronavirus.
For free. I'm not sure. I'm not graduating this month anymore, so.
I'm graduating, but I didn't sign up for the virtual freaking graduation bull crap. I just want my freaking degree.
Yeah, that makes sense. No, I would whenever everything went online, I had 6 online courses, and my speech and my history were giving me like 6 assignments each week. So I said, I can just pick up gen eds in the fall. So
All right, so like originally they had the 12th through the 18th, and everything was supposed to be pushed back. So I'm assuming, and I want to get a good answer on this, I'm assuming that we're going 19th through the 25th. 25th is probably Labor Day. Let's plan on the week of the 18th through the 22nd is when we'll do our final exams, and I need to schedule your 2:30 presentations for sometime around there too. So we'll hash all that out on Monday.
okay,
Alright.
sounds good.
You all have a good weekend and stay safe.
You too.
Yeah.
Hey, Kenzie,